Here we go. We have a question: maximum count of positive integer and negative integer. You have given an array. This is a sorted array. We need to return the maximum between number of positive integers and the number of negative integers. In other words, if the number of positive integers is POS and the number of negative integers is NEG, then return maximum between POS or NEG. Note, 0 is neither POS or 0 is neither positive or negative. In this case, we have 3 positives and 3 negatives. So maximum between 3 and 3 is 3. We have 3 negatives and 2 positives. So maximum between 3 and 2 is 3 only. In this case, we have 0 negative and 4 positive. So maximum between 0 or 4 is 4. So this question is pretty straightforward. We can solve it in order of n time complexity, but it is given that we have to solve it in log n time complexity. So let's build the approach. I will take this example. So let's suppose I have given -3, -2, -1, 0, 0, 1 and 2. So I will apply binary search for negative position, and in this I will check my last negative position, or this is the last negative. So negative, 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 this is the last negative position. So I will again apply binary search for positive elements, for positive position, and I will get the first positive position. So I will get this position. So I will get this position for negative, this position for positive. So I will check what's this index: 0, 1 and 2. So it means we have 3 negatives, and this is 3, 4, 5, 6. This is the fifth index. So what's the length? Length is 7 minus fifth, which means we have 2 positives. So that's how this approach will work. I will apply binary search. I will create a binary search function separately for positive, separately for negative. So let's build the let's code this. So first let's get negative position, and so let me write BS for negative, and I will pass nums. This is the positive position. Binary search for positive, I will pass nums. Then I will get I will create this function binary search for negative. I have an array L0 R points to so let's say R points to this index. So binary search for negative. So let's suppose for this example we don't have negative. So for this case the answer will be -1, right? So then let's apply binary search L less than or equal to R. My mid is L plus R minus L by 2, and if array of mid is negative, so this is negative index, so this will be my valid index, or the first occurrence will be on the right side, right? Or if array of mid is equal to 0, means we have to means the negative values is in the left hand side, or mid is positive, so still it will be on the left hand side. Then let's return the answer. Same for positive. So this is for positive. If positive value is not there, it will be length. So this is an array. If this is negative, so positive values will be on the right hand side. If this is positive, if this is 0, positive value still on the right hand side. If this is positive, so this will be my valid answer, or the answer is in the left hand side. So positives how many positives, first of all let's find how many negatives we have. Negative position plus 1, negative position plus 1, and positives is nums length minus positive position. Then let's return between negative and positive. Let's run this. So this is not string, this is an array, and working fine. Let's submit this, and working fine. So we have solved this question with 100% bits. Time complexity is log n for both of the function, for positive, for negative and positive. So time complexity is log n, space is constant in this case. Thank you all for watching.